All right, so we are going to do, we'll just put a 60. Oops. I didn't change my stuff over. Let's do this. Do that. Make this 2 point. There we go. All right. So we're just going to do the practice problems, okay, on lesson 60, just to kind of get in the swing of these. The first one's not too hard at all. After that, you know, it starts getting a little bit complicated, but let's do it. All right. So A. They give you two vectors. They give you a v vector. Now, when they put vectors, they put the double bar thing there. But I don't know. That always bugs me. I've never seen that. When I was in college, I don't ever remember seeing that. Every time I've taught this I've taught this probably out of a couple different books. Nobody ever does that. Usually you see it like this, especially like physics. Because the lesson we're going to do today, 61, it's basically like taking a physics class. All right. And every time I've always seen it, they always do vectors like this. All right. Now, when you have a book, they usually put it in bold or something like that. They may not even put like an arrow. They just might make it bold. But I think that's what they do it in the book sometimes. But it's kind of hard to do bold when you're just writing. So I put that little half arrow thing over top of it. That means a vector. All right. So let's write this vector out. Plus negative 2 j, like that. We did that I and j thing last time, did we? Or did we not? Did we do the I and j? Can't remember if we did. It just means that, I don't know why they picked I and j, but what that means is this is the one that's going in the x direction, and this is the one that's going in the y direction. Okay, so the I indicates the x direction, the j indicates the y direction. And I remember seeing that in college, and when I used to teach physics, you know, they would write it like that. So that is a pretty a common way to write vectors. And negative 3i plus 7j. Now this is not the I where it's like the imaginary number stuff. Remember that? Okay, it's not the square root of negative 1. It means it's something completely different. It just tells you which direction that's going. So these are in component form. It just means you're going 5 in the x direction and negative 2 in the y direction. That's all it means. And what they want you to do, and they actually make this very easy for you, they want you to figure out what this is. 4 times the vector v minus 3 times the vector w. Okay? And you basically do what you think you're going to do, I think. I think you'd probably figure this out on your own if I didn't even tell you. This is 4 times this vector. So what do you think? Here's vector v right here. What do you think you're going to do to this whole vector right here? Yeah, and just distribute it through, right? Yeah, it's pretty self-explanatory, don't you think? But we're going to write it out. So I'm going to go 5i. Now you could put plus negative, but I like to put just minus. Doesn't that look a little bit better? Like that? Yep. And then we're going to subtract. So there's 4v, and we're going to subtract 3w from it. So you're just going to do the same thing. So really, it just ends up being just a real basic algebra problem, doesn't it? All right. So you distribute. So that's 20i minus 8j. Okay. And then look, negative 3 times negative 3 is positive 9i. Then distribute the negative again, right? Don't forget that. That negative has to be distributed as well. So it's negative 3 times positive 7, which is negative 21j. We're not quite finished, though, are we? What do you think we can do to this to simplify it? What are we going to add together? The i's and the j's, right, exactly. So let's add the i's. It's 20i plus 9i, which is 29i. And let's make that look like an I. And then negative 8 minus 21, that's j. That's supposed to be a j. It looks kind of weird. But negative 8j minus 21j is negative 29j. All right? And that's probably how I would write it. I think, I don't know if the book does this or not, but I put a or. So maybe the book writes it like this, plus negative 29j. That just looks like too much extra stuff, don't you think? The parentheses, the plus, that's a lot cleaner. It's a lot, you know, it's a lot slicker, don't you think? All right. Well, that was easy, wasn't it? It's a good way to start off a morning, right? Just with an easy problem. Well, let's keep going. Hopefully they stay as easy. Do you think they will? Nope. Probably not. Be honest with you. They usually get a little tougher. All right, let's do this. Now this is really super important, especially for the new lesson that we're going to, well, the lesson 61 that we're going to hopefully get to today. you're going to have to do this quite a few times. So this should be kind of like second nature to you. It says find the magnitude and the direction. So find the magnitude, okay, and the direction. And I believe we did some of this in lesson 59, I think. I don't know. It's hard for me to remember what I did when. I can barely remember what I did this morning, so what I did last week, who knows. Of this vector. So it's u. That's a weird looking u, but that's my u. And so here's my vector right here. Okay, and we want to find the magnitude and direction. So what I'm going to do is make a little xy axis and put this on the x and y axis. And it doesn't have to be like exact to scale or anything like that. I don't even need graph paper. I just kind of figure out what this is. Remember, this is 7 in the x direction, isn't it? So we start at the origin, so we go 7 here, and then we go what? 16 where? Up, right? Because it's positive. The j means the y direction. So we go 7 over, and then 16 up. I'll just estimate it, okay? Might not be exactly to scale, but it's close enough. And what we're going to do is we're going to connect from where we started to where we ended up. All right with that? So there's our vector. So that's the component form, but what we want to do is we want to change it from the component form into the magnitude and direction. The magnitude means how long that line is, so I got to figure out how long that line is. The direction means, remember that from the positive x-axis, if I go counterclockwise, what angle is that going to be? All right, so that's what I got to figure out. I got to figure out the length of that line, and I got to figure out that angle. I'll call it theta. Okay, you with me so far? So what we're going to do is we're going to make a right triangle out of this thing. So I'm just going to drop this. I always drop it to the x-axis. Some people might say, oh, I'm going to take this over here. You can make a right triangle out of it if you did that, right? But I think you're going to, this lends to a level of consistency if you always take it to the x-axis. And you're going to find some stuff that's true that's really going to help you out with this lesson 61. Right? So how far over, remember, how did we get to that point? We went over 7 and up 16, right? So what's the length of this side of the triangle? 7. And what's the length of this side of the triangle? 16, okay? Now, it's a right triangle because we went positive, or we went to the right, then we went up, right? So how am I going to find the length of that line knowing those two numbers? Starts with a P. Pythagorean Theorem, good. Okay, so I do the Pythagorean Theorem. So let's do that. And I'll tell you what, we can kind of shorten a little bit. You know you're going to find this. I don't know what you want to call it. We'll call it R and put a little vector over it. Actually, you know what? They called it U, so let's call it U. All right. So there's vector U right here. That's what we want to find. We want to find out how long it is. So if I want to find vector U, remember it would be 7 squared plus 16 squared equals U squared. But I'm just going to write it without the squared here and take the square root already. So it's going to be 7 squared plus 16 squared. Chuck that in your calculator and you get approximately 17.5. Okay? And that's the magnitude. That's the magnitude of U. And I think when I said the bar thing, I think what they do the magnet, is that what they use, the bars, those double bars? I think they use it for the magnitude of it. I don't know. But I'll show you a way that I'm used to writing it in a little bit. I'll show you what I usually do. So that's how long that line is. Now we got to find the direction. Okay, there's some different colors. Too much orange floating around. Let's go blue. All right. Now I got to find this direction. Well, I've got a right triangle, and I know two sides of my right triangle. Actually, I know all three, don't I? Because now I know U. But what I wouldn't do, you could do this and it wouldn't be wrong. And I noticed that he did it on lesson, I think it was 61. He actually used this value right here. But I think they gave this to you exactly 7 and exactly 16. Is this exactly 17.5? No, it's approximately, okay, because the decimal keeps on going crazy, all right? So we rounded it to 17.5. I wouldn't use a rounded number if I didn't have to, okay? If that was my only choice, sure, go ahead. But I would use the exact numbers as much as possible. Does that make sense? So, and plus, this also lends to consistency. If I'm going to find this angle, look, this is opposite, this is adjacent. Which trig function uses opposite and adjacent? SOHCAHTOA. Remember that? It's the tangent, right? So the tangent of that angle is equal to the opposite over the adjacent. You with me? And now I got to solve for theta. Do you remember how to do this on the calculator? I take the inverse tangent of 16 over 7. So let's put that into the calculator and see what we get. So I'm going to hit second function tangent of 16 over 7. 16 divided by 7. All right. I think I'm still in degrees. Yep, I am. All right, so we'll round it to one place. So if I round it to one decimal place, that's 7 rounds of 3 up to a 4, so 66.4 degrees. So that angle is 66.4 degrees. So I've got a magnitude right here, and I've got a direction right here. This is how I would usually write it. I would just say 17.5. A lot of times I'll say at, that stand for at, and then 66.4 degrees. So that would be vector u. The book doesn't use that at thing, but I've seen that quite a bit other places. There's all kinds of different ways you could write this, but that's how they do it. Or that's how I do it, I'm sorry. It's not how they do it. So that's not so bad, is it? You okay with that? Yeah, it's just right triangle stuff, okay? It's just knowing that this is basically just an ordered pair, isn't it? All right, so you put the point where the ordered pair is, you make your line, and then you figure out the length of it just by using Pythagorean Theorem, and then you find the angle. In this case, you use the tangent. In almost all the cases, we're going to use the tangent. As long as you take this down to the x-axis, this will always be the opposite and adjacent, so you can use the tangent just about every single time on this. All right, so that's pretty helpful. You good with that? All right, we're going to use that quite a bit. So that's one of those things that needs to be pretty well understood, all right, because we're going to use it a lot more than that. All right, I think that's all the vector stuff they give you. Well, they give you one more. It's the last practice problem, but then they throw in some of the older stuff, and it's always good to do that, isn't it? Go through some of the older stuff. So that's what we'll do right now. Try to go a little quicker now so I can get to 61. All right. This is practice C, and it says, oops, let's write it like this. It says to simplify this thing right here. So what's the cosine of x? Remember, this is some of that trig identity stuff. I don't know if you like that stuff or not, but you hate it? Is that what you said? Wow, that's pretty strong. There is, but remember, you can use that chart, right? So there's a lot of stuff that some teachers may have you memorize that I'm not having you memorize. So, but you have to recognize it. So what I would do is when I do a problem like this, I'd always have that chart sitting right in front of me, okay? And that could be pretty useful to you. All right, you may or may not. I don't even think you have to use that chart on this problem right here. But the hardest part is, where do we start? What do we do first? You know what I mean? So, and look, I'll let you in on a secret. If I'm looking at it, I'm writing all this out, and so I don't want to make a whole lot of mess ups and then mark it out and try another way. Try it one way, it doesn't work, then try another way, and then I got everything all scribbled out. So sometimes when I look at it, I have a general idea what I want to do, and then I'll look at the guy's video on how he does it, and I'll just kind of sneak through. I'll just kind of scroll through, not watch the whole thing, and I'll see what he did, what approach he took. I'm like, okay, so either I was doing it wrong, or not wrong, but I was doing it maybe a more difficult way, and I looked at his way to do it, and I'm like, oh, that's better. But most of the time, I kind of figure out what he's going to do. But I do cheat a little bit, right? Just to make sure that I'm going the right direction. I don't want to do all this work, right? And then go back and, oh, man, I went the wrong direction. I should have done it this way. So anyway, so that's me too. And I'm the teacher, for goodness sake. So I can imagine, first time seeing this kind of stuff, it can be kind of difficult. But first thing I see right here is this thing that's being squared. So what do you do when something's being squared? Yeah, exactly. Okay, so watch. If I ask you to square this thing, is this a squared plus b squared? No. It's not, is it? So what do I have to do? And you said it right. You said do the FOIL method. So I'm going to have to write a plus b times what? Another a plus b, right? And then I do the FOIL. So guess what we're going to do here? It's not just cosine squared plus sine squared, is it? I'm going to have to go cosine plus sine times, put them both in parentheses, and then cosine plus sine. I mean, there really wasn't much more that you could have done with this, is there? I don't know. Do we have a trig identity with 2 cosine I'm looking through here. I don't see anything like that, do you? Like the 2 cosine sine thing? Nope, I don't see anything like that. So there's really nothing we can do here. The only thing we can really do is just square this. Wouldn't you agree? And we're just going to write this last thing down. And so what I want to do is I want to do FOIL method with this. All right? So let's do it. First outside, inside, last. So the first, cosine times cosine, is a cosine squared. The outside is cosine sine. And I'll just do every step here. I could skip ahead a little bit, but I don't want to mix you up too much, okay? You follow me with that? That's the outside. The inside is also, that's sine cosine, but isn't that the same thing as cosine sine? Okay, so I'm going to write it in the same order just to make it look a little bit nicer. Stop me if you don't know what I'm doing, okay? All right, you see that? So that's outside, that's inside, and what about the last? That's going to be what? Sine squared. Good. Okay. Now, that's all this thing right here. All right. So this cosine plus sine parentheses squared is this crazy thing right here. Minus what? 2 cosine sine. Well, we can do something with this before we do anything else. What can I do with that?
The cosine x and the sine x can't be 1.
Well, no.
They just, when you put them together, they equal 1.
Do they? It's not squared. It's not cosine squared plus sine squared. Oh, the cosine squared and the sine squared. Okay, I'm sorry. I was thinking you were talking about these two. Because that's where I was looking, and my mind was headed there. But I know exactly what you're saying. You're right. The cosine squared plus the sine squared is a 1, right? That's one of our identities. Very good. So,
and then also the cosine and sine x will add up to be 2 cosines sine x, and then you have a negative cosine.
Yeah. So this cosine, let's do what you said first. Cosine squared plus sine squared is a 1, right? Plus. Now let's do what I said. Cosine sine is what? 2 cosine sine, right? And then, so you're done with all that stuff, and then you got to throw in that minus 2 cosine sine. So this actually works out pretty nice and easy, doesn't it? So what happens here? Yeah, those add up to 0, don't they? Do you see that? 2 of these minus 2 of these is 0 of those. And then what's your answer?
1.
Just plain old 1. Isn't that crazy? Look at that mess. All that stuff right there is just a 1. Right? And what does that mean? That means I could put any angle in here I wanted, right? I could put like a 27 and do it in your calculator. Put cosine of 27 plus the sine of 27, square it, right? And then put the 2 times the cosine of 27 times the sine of 27, subtract the 2, and what does it all come out to? It comes out to a 1. It's crazy. All right, let's keep going. That wasn't too bad, was it? That one?
I like that.
Yeah, I like that one too. That was pretty good. It'd be nice if they all came out that easy, wouldn't it? The hardest part was understanding to do the FOIL method, right? On that. That was the key to that problem. The rest of it was pretty simple, but that was the key. All right, here's one of these deals. We've done this a little bit before, something kind of like it. It says if the sine squared equals s. Sometimes there's like little tricks that you kind of have to think about. And then that's equal to t. Then it says what is, that's a weird A, let's try that again. What is the sine of 2x minus the cosine of 2x? And they want the answer in terms of s and t. All right. So what in the world are we going to do here? How in the world does this stuff right here relate to the sine square? I mean, I don't have any squares in here, so I don't even know what to put in for what. So where do we look? To our trig identity chart, right. So take a look at it. Take a look at your chart. Do you see anything that we could substitute in? I'll give you a hint. Look at sine of 2x. Do you see anything where it says sine of 2x? You're doubling the angle, aren't you? You see that? So this must be a what? A double angle identity, right? Because it's 2 times that angle. So what's equal to the sine of 2x?
2 sine cosine.
Yeah, so let's do that. And you're like, well, how does that help us? That still doesn't give us a square, does it? Right? And I'm on board with that. But let's just see what happens with this. So it's, what is it? 2 sine x cosine x? Okay. So that's what the sine of 2x is. Look at the cosine of 2x. That's a little different because they give you 3 possibilities, don't they? All right. What I would probably do, now you got 3 choices. You got the cosine squared minus sine squared. You got 2 cosine squared minus 1. You got 1 minus 2 sine squared. Everybody see that part of it? Which one do you use?
I was thinking the top one.
Why the top one?
Because you have the sine squared x equals s and cosine squared x.
Exactly, because that first one on the cosine of 2x, it has a sine squared and it has a cosine squared. You kind of know what they are, so we can probably plug those in, can't we? So it's minus, right? Now you got to be careful with this. You're subtracting this whole thing, right? So what do you have to put here? Put parentheses. And what was that again? Cosine squared minus sine squared? Yeah. Cosine squared minus sine squared. And it's very important that you put that in parentheses because you're subtracting that whole thing, right? So let's do this. Okay, let's do this first. Let's just get rid of that parentheses and that kind of thing. Let's just distribute this negative through both of these before we do anything else. That just cleans it up a little bit, makes it look a little bit nicer, and then we can figure out what we want to do. So this is going to be minus cosine squared plus, do you see the difference there? Sine squared. We good with that? All right. The next part is the part that's really crazy. I don't know if I would have figured this out, okay? So I'll just tell you straight up what they do here. Now, what's nice about this cosine squared, what can we do now to this cosine squared? Remember, we want to write our answer in terms of s and t, don't we? Well, look up here. What do they tell you? Yeah, plug it in, right? So look, cosine squared is t, isn't it? So what can I do here? Minus what? T. You see that? Because they tell you that the cosine squared is equal to t. What else can you put in? Yeah, put a plus what? S. But this is a little issue right here, isn't it? Because they don't tell me what that is. But what if, I'll do this in a different color so it shows up a little bit. Watch. Remember, the sine squared is equal to s. But I just want to find what? The sine. Okay? So what am I going to do to get the sine? Take the square root. Good. So what's the sine of x going to equal? Square root of s. Do you see that? Okay? And it's the same thing with the cosine as well. So the cosine of x would equal what? The square root of t. So that was a little tricky, wasn't it? Probably didn't think about doing that, but that's what we want to do. Okay, so let's go back to this color. Keep it all the same. So we're going to get 2. And again, what is the sine of x? It's the square root of s. And what's the cosine of x? It's the square root of t. And that is our answer. I think they give you choices, don't they, with this? Yeah, and that was one of our choices, I believe.
Well, they combined the s and the t under one.
Oh, did they? All right, let me take a look at it. That was D, right? 2 plus. Oh, they put plus s minus t. I don't know why they did that. Oh, I see what you're saying. Yeah, they did this. They put 2, and then they put st, and I don't know why they put the s first, but it doesn't make any difference, does it? All right, but would you agree that this and this are the same exact thing? Mm-hmm. Yeah. So, and that was letter whatever. I don't know. What was it? E? No. B. Right. So it was letter B is our answer. All right. Let's move on. That was a little bit tricky. I agree.
We didn't even show one of those in the lessons.
Yeah. Yeah. They just figured you can figure it out. All right, let's do another one. 1 minus the cosine of 140 degrees over 2. And let's see, they give you any instructions? No, they just say figure it out, right? Oh, they give you, it's multiple choice again, so they give you all these different choices. So if you look at all the choices, none of them are like decimal things, are they? So it's not a matter of just throwing this into a calculator and getting some decimal number, because none of your choices are decimal numbers, right? I mean, I guess if you really got in a bind, you know what you could do? It's not cheating, but it's kind of like going against what they're trying to teach. You could put this into a calculator, get a decimal, and then take all those possible choices, put that in your calculator, see which one's the same thing, all right? But that's kind of getting around the issue, right? That's not really doing what they want you to do, all right? So what they want you to do is this. They want you to look at it as, let's see, what else do they tell you? That's all they tell you, right? Yeah, and so they want to, let's see how I did this. Oh, okay. All right, let's take a look at this. This kind of looks like one of our trig identities. It's a big thing divided by 2. Do you see anything in here where it's like something and then over 2?
It would be sine of the half or cosine half. Oh, it's minus, so sine half.
Yeah, it kind of looks like that. It doesn't look exactly like it. Right, you're right. It's the sine of 1/2 x. Do you see that? So let's write that down. The sine of 1/2 x. It kind of looks like it. Okay, it's not exactly it. So you got plus or minus, big old square root, and then you got 1 minus the cosine of x over 2. You say, well, how does that relate to this? I don't see any square roots or anything, but I see a 1 minus cosine of something over 2, don't you? See, so that looks just like this. Agreed? Here's another way we could write this. Let's do it like this. So how would I figure out what this is equal to? Because this is 140, right? I could put a 140 in for this, but this isn't under a square root, and this is. So let's do this. Let's get rid of the square root. Then this will be equal to something. Does that make any sense? I don't know if I explained that very well, but what I want to do is get this thing that I've got in a circle by itself. So how do I get it by itself? Square it, right? Square both sides. So that square will take care of the square root. So what do we do over here? We square that. Okay? That looks kind of weird with a squared and 1/2 right here. So what I'm going to do is I'm going to write it just a little bit easier for us. I'm going to do this. Actually, let's do this. Make it x over 2. You see that? That's 1/2 x, and that's 1/2 x as well, isn't it? I don't know about you, but that makes it look just a little bit nicer, I think. So let's see. What is the x here? It's 1 minus the cosine of what? 140. So the x is 140, isn't it? So where am I going to put that x? I'm going to put it right there. Where am I going to put that 140? I'm going to put it right there for the x. You see that? Mm-hmm. So I'm going to put 140, but what do you have to do to that 140? You have to divide it by 2, don't you? Okay? And so what's that going to be? That's going to be sine squared of what? 70 degrees. Do you see that in any of your choices?
Yes.
Yes, you do. It's letter E, isn't it? So this is not something that they don't ask you straight out, like, just simplify this, right? Mm-hmm. They say, what is this equal to? And they give you all these choices. So you got to figure out, okay, I got to make this look like one of my choices, all right? And all the choices have like a sine, cosine, or a tangent squared in front, don't they? All right, so when you look at this, you're thinking, okay, how can I make this thing look like a squared, either sine squared or cosine squared or whatever? Well, get rid of the square root, right? That makes it look like a sine squared. That's one of my choices, says sine squared. You follow me? So this is kind of a different way of thinking. It's not like they're just saying, okay, just simplify this. Because I probably would have not taken this and simplified it to this, right? But since this is one of my choices, it kind of gives you an idea where you want to go with it, right? So you're looking at this and like, what in the world? And you look, okay, well, I've got cosine, I got tangent squared, cosine squared, and sine squared. Those are all my choices, right? So how can I make this look like one of those? Well, you definitely saw that this looks like your half angle identity, right? So it's like, oh, it's the sine of x. It's not the squared, so I got to get rid of this square root. Ah, that does make it sine squared. And then you say, well, if this is 140, I'm going to put the 140 right there. And then I got to divide it by 2, right? And then there's your 70, and that looks just like one of my choices. So that was a little odd, wasn't it? Yeah, I agree. Let's go to the green. So let's do letter F, and then we'll be ready for 61. It seems like I always don't have enough time to do the last lesson that I have planned, but we'll try. Letter F. Oh, it's a word problem, right? Plane is flying southwesterly, okay, so that it makes a 60-degree angle with the east-west line. Well, this would be west. This would be east. It's going southwest, right? So it's going to go in the third quadrant. Would you agree? All right, and it's going to make a 60-degree angle with the east-west line, the x-axis, right? So what do we have to do? We're going to go 60 degrees from here. So we're going to go like that. Does that make sense after you read the words? It's going southwest, but 60 degrees with the east-west, what do they call it? The east-west line. All right? So that angle right there is 60 degrees. That's probably the hardest part of this problem right here, is just understanding how to set the thing up. But I think that makes sense, doesn't it? Southwest. It's got to go in this quadrant, right? Because that's west, this is south, this is between south and west, right? And it's 60 degrees from the east-west line. And the question says, what are the components of the vector? So remember what we did before? They gave us the components and we found the magnitude and the direction. What they're doing now, and it says they're flying 55 miles per hour, so that's our magnitude. This time they give you the magnitude, they give you the direction, and you have to find the components. And what are the components? That's the x, and that's the y. Okay? Yeah, eventually that's how they probably want you to write it, but we'll just call it x and y right here. So how do we solve for x and y? Well, it's a right triangle. We're just going to use our trig. They give you a hypotenuse, they give you an angle, don't they? Right? Or you could use 30, 60, 90, couldn't you? We'll just go straight trig on this one, okay? So what do we have? Let's solve for x first. So this would be adjacent. They give you the hypotenuse. Which trig function uses that? It's the cosine. The cosine of the angle is equal to the adjacent over the hypotenuse. And you're going to see a common thread here. You're going to see, as long as you make your triangle up to the x-axis, you're going to see that your x is going to be the cosine, and your y, you're going to use the sine. That's going to be a nice consistent thing that's always going to happen, okay? And then we solve for x, so what do? You multiply by 55, so x is 55 times the cosine of 60 degrees. Now, it's in the third quadrant, so the x is going to be what? Is it going to be positive or negative? It's going to be negative. Now, on your calculator, if you just put 55 cosine 60, it's just going to give you a positive answer, okay? But we realize it's in the third quadrant, so it has to go negative, so we're going to go negative. Then you put that in your calculator. I'll let you do that. It's negative 27.5. Okay. Now, if we want to find the y, look what trig function we use. We use opposite over hypotenuse, which is the sine. So it's the sine of 60 equals opposite, which is y, over the hypotenuse, which is 55. Multiply both sides by 55, so y is equal to 55 times the sine of 60. All right, put that in your calculator. That's also going down, isn't it, in the third quadrant? So that's also going to be negative, and that's going to be 47.6. So that's your component form. You could write it with the I and the J. I don't know if they do that or not. 47.6J. All right. That would be okay if you put the I and the J. Again, I don't know if they do that or not, but that's what you could do. If you notice this, watch. Look at the x. The x, it's the hypotenuse times the cosine of the angle. What's the y? It's the hypotenuse times the what? The sine of the angle. You see that? So that's something that really comes in handy a lot, is understanding that part of it. All right, that the x is the hypotenuse times the cosine of the angle. The y is the hypotenuse times the sine of the angle. As long as you stay consistent with making your triangles up to the x-axis, that's going to happen a whole lot. I don't want to say every single time, I don't know, but pretty much every single time that's going to be true. You okay with that? All right. So now we're finally finished lesson 60. Let's go to 61. Okay. So lesson 61. What I decided to do, well, actually, let's see. I went through some. You know what I'll do? I'll just go straight to the examples, to the practice problems. Is that all right? Because I have all this other stuff written down from when he was teaching it in the lesson, but since we only have not even 20 minutes left, so I think it would probably be good if we just did the practice problems. So let's do the practice ones. Let's do A. We actually did one like this already, so let's do it. There's a little bit of a change to it. It's a little bit tougher than what we did in the other one, but it's pretty close. So this is our vector. And we want to change this. We want to find the magnitude and the direction. So I'm going to go kind of fast. If I go a little too fast, you can always go back at the video and look at it, okay? Let's do this in a different color here. Here we go. All right. So remember, this is kind of like an ordered pair, isn't it? So it's in our component form. We go -9, we go +27, so it's probably up here somewhere. And I want to go from the origin to that point. I want to make a right triangle, so I always take this down to the x-axis. I always make my right triangle down to the x-axis. Don't take it over to the y. Make it look like this, okay? And what do we have to find? We have to find the magnitude, and we have to find the direction. But if you look at this, our direction is a little bit different. Since we're in the second quadrant, remember where we start to do our direction? We always start from the positive x-axis, and we go counterclockwise. So we have to go here to there. So that pink arrow right there, that's the actual angle that we want. We have to find this blue theta right here, but our final answer is going to be this pink one. Okay? So keep that in mind. Let's find the x and the y now, because again, we want to find this, which is we're going to do Pythagorean Theorem. So how far over did we go? We went over 9. How far up did we go? 27. So we do Pythagorean Theorem. Okay, so it's 9 squared plus 27 squared. We take the square root for Pythagorean Theorem, and you get about 28.5. All right, so that's the magnitude of vector P. But we also have to find the direction. Well, I've got a little right triangle here, so I've got opposite and adjacent, so I do the tangent. The tangent of theta is equal to opposite, which is 27 over 9. That's a 3. But you can throw it into your calculator. Make sure you hit second function tangent, right? It's the inverse tangent when you find the angle. And you get, let's see, about 71.6 degrees. But that's not my final answer, though. That's this angle right here. I'll put it in here. 71.6. But we want to find the pink angle. So how in the world do I find the pink angle? I know this one. That's it. You just subtract it from 180. That's all you have to do. Pretty easy, isn't it? Because watch, if I went all the way to here, that'd be 180. But I back up a little bit, right? Back up 71.6. I take away 71.6, and I got what's left over. So it's just a matter of going 180 minus 71.6, and that gives you 108.4. And that is your final angle. So if I wanted to write my answer out, you could say vector P is equal to 28.5. You don't even have to put the units, or there's no units at there, at 108.4 degrees. So that kind of sums it all up, doesn't it? And that's a vector. A vector has to have magnitude and direction. That's the vector. All right? Let's do another one. This one's weird. I haven't seen this one before. This is the first time I've seen anybody do this one. They call it a unit vector. Do you remember the unit circle? The unit circle means, and we drew triangles in there and stuff, it meant the hypotenuse was equal to 1. All right? So this says, find the unit vector I just had never heard of this before. Find the unit vector that's in the same direction as this vector. Okay, this is vector u. And here's the vector that they give you, minus 24j. All right? So let's do this first. Let's figure out where this is, and then figure out what we're going to do with it. Okay, what in the world do they mean, the unit vector? This is one of the ones where I had to watch his explanation for this, because I had never heard of a unit vector before. So it's a little bit different. Let's plot this, 7 and negative 24. So you go over 7, you go down way down here to negative 24. And let's go ahead and draw our little arrow to there. All right. And if we want to take this up like this, we've got a nice right triangle. How far over? 7. How far down? 24. Okay. What about the length of this one? How can I find the length of this? Well, I can do Pythagorean Theorem. Okay. Once I'll just let you do that. It actually comes out to a nice whole number. This is one of our nice, remember, did we do 3, 4, 5 triangles and that kind of stuff? This is one of our special triangles. This is, they call it a Pythagorean Triple, okay? So 7, 24, 25. It's nice if you recognize it, then you don't have to do all that work to do Pythagorean Theorem to figure it out. But it only takes you a second to do Pythagorean Theorem. Anyway, we got this. So that's the length. The length from here to here is 25, okay? But watch this. This is what's weird about this. And I understand what they're doing. I just never heard of it before. What they want you to do is they say a unit vector. Remember, a unit circle, the hypotenuse was 1, right? Unit basically means 1. So what they want to do is find out what would this length be, this 7, this x direction, and what would this y direction be if this wasn't 25, but it was only 1. So what if it just went to here? Okay, do you see what they're doing? They're saying, okay, what if this wasn't 25? What if it was 1? What would the x direction be, and what would the y direction be? How long would this be, and how long would this be? That's what they're asking you. Okay, what would the components be if this was actually a 1? Well, how did you get a 1? This was 25, right? So this was 1/25th, wasn't it? Of the whole thing. So what do you think this part's going to be? It's going to be a 25th of this whole length. So it would be what? 7/25. Good. So this one, this little one right here would be 7/25. What would this one right here be? This little, it would be 24/25. Exactly. Right? In order to get a 1, this would be 25/25. Okay? You see that? Because it's 1 out of it's out of 25. So this would be 7 out of 25, and this would be, oh, I put 24 here. This would be 24 out of 25. It's kind of weird, isn't it? So the components, what would the components of that vector be then? It would be, how far over to the right did you go? 7/25. We'll put an I right there. That's positive. And how far down did we go? Put a negative. We went 24/25, and that would be in the j direction. And that would be the unit vector for something like that. It is weird, isn't it? Okay, it's not hard to do though, is it? Once you understand what you're trying to do. All right, they're just saying what would the x be and what would the y be if the length of this was only a 1, right? Still going in the same direction, right, as the original one. But what if this was only a 1? What would we do? Well, we take it divided by 25. So you just take this divided by 25 and this one divided by 25. And that's how you write it. Okay, let's move on. Oh man, we got... Oh, I wish we had finished. One day, I wish I would finish the whole thing. We need like an hour and a half. That's what we need. You're probably thinking, no way. Are they really? Is that right? I guess they only give me an hour because I got to get back to school. My word, there's no way in the world I can do this, and I'll try it. I'll give it a shot. When does your next class start? Does it start right at 9:30 or does it? Okay. But I got to be back, so I can't like stay any longer. Let's do C. This is one of those force ones, isn't it? All right. So let me just kind of get you started on this. It's saying, did you understand any of that one? I didn't watch his explanation, so I didn't really. I was just going by the book, okay, and just taking notes on my own from the book. But it's like this: you have one ball sitting here. It's like pool, right? You know, you hit a ball and one goes in one direction, one goes in the other direction. Okay, so it's like one ball hits it in one direction, the other ball hits in the other direction, and you know, what are the forces? What are the combination of the forces on it? So basically, it's like this. That's our horizontal right here. So one ball is hitting it at 60 degrees. So I'll tell you what, let's do this in different colors. Man, if I had like 15 more minutes, that'd be good. I could do this. All right, so one ball is hitting at 60 degrees right there. And their drawing is a little bit confusing, but hopefully it'll make a little more sense when you see this. And the other one, and by the way, it's 65 newtons. Newtons is a force, okay? We won't talk about that too much. I'll just put the 65. So the magnitude is 65 and the direction is 60. Now the other ball hits. Let's do this in a different color. Orange. Let's go this pink color. All right. The other ball hits. It's the same force. It's still 65 newtons of force, but it's going off at a different direction. So I want to try to keep the lines as close to the same length as I can, because the length of the line indicates how much force. So as long as they have the same length, that's the same force, but it's off at a different direction, like this. Okay? And what we want to do is we want to find the total force acting on that one ball right there. Okay? And how do we find the total force? We add them together. All right? Several ways to do this, so this is probably the best way to do it. I would break it down into its components first. Okay? So let's take the yellow one and very quickly. Oh my, I only got like 1 minute. There's no way. So I'm going to break it down. I'll tell you what, I'll just do it like this. I'm just going to break it down into its components. I want to find the x and I want to find the y. We've done that twice already today. I'll let you figure that out, okay? Remember, it'll be 65 times the cosine of 60. Remember that? The x is the magnitude times the cosine of the angle. The y is the magnitude times the sine of the angle. So x on this vector right here, we'll call this vector A, and we'll call this one B. Well, I'll change colors in a sec. All right, so x is 32.5 on the yellow one. I'll let you do the work on that one. And y is 56.3 on the yellow one. Now, you do the same thing with the pink one. All right, take that up here, find this x, find that y. And so, again, it's 65 times the cosine of 30. That would be the x. And that will give you 56.3. And let's do the same thing for the y, except you're using the sine. And that would be, now watch, the sine, this is going down, isn't it? The x is going to the right, the y is going down, so you're going to put a negative right here because of that direction, 32.5. That kind of makes sense, doesn't it? Because we did that earlier, right? We took it and broke it down to its components, and that's basically all we did right there. So what I want to do now is I want to add these together. How do I add these vectors together? Well, I add the x's together, and then I add the y's together, all right? And I'll just show you what I get. When I add the x's together, I get 88.79, right? And that's in the x direction. When I add the y's together, I get a positive 23.79. They say round it to 2 decimals. That's why I used 2 decimals on this. Okay, so that's the component form. But I want to take this component form and change it to magnitude and direction. So really, everything on this problem is kind of what we did on lesson 60, but it's kind of combined. All right. So now I want to change this into magnitude and direction. All right. So how do I do that? I go over 88 and I go up 23, and it would be right there. Oops. Okay. And then, so now we drop it right here. This is 88.79, and this one is 23.79. What do I have to find? I want to find that angle, and I want to find this magnitude. How do I find the magnitude? Pythagorean Theorem. Once I do Pythagorean Theorem, I get 91.92. I'll let you do Pythagorean Theorem just to make sure you can get that. So that is our vector. I'll call it R for resultant vector. Okay. Now I got to find the angle. How do I find the angle? Tangent, that's right. And then I take the inverse tangent, right? 23.79 over 88.79, and I get 15 degrees. And I'm basically done. So if I want to write my final resultant vector, it would be 91.92. These are forces, so I'm going to put a unit on there. I'm going to put newtons at 15 degrees. I don't have to add 180 or subtract 180 on this one, do I? Because it's already in the first quadrant. Okay? And that is the final resultant force on that billiard ball or whatever they're talking about right there. Okay, does that make sense? All right, so that shouldn't be too bad, right? You got two of them, you break them down into components, you add the x's, add the y's, then you have a component vector, you just change it, find magnitude and direction, and you're good to go. If you can do that, you could probably do the next 2 or 3 of those problems, all right? All right, hope that helps. Have fun on all your other classes. We'll see you.